What if I told you that life might already know how to survive on Mars? Not humans, not aliens, but something far smaller. Something you've used in bread. Scientists have discovered that tiny yeast cells can survive shock waves, toxic soil, and extreme stress, conditions that exist right now on Mars. And what they found inside these cells could completely change how we search for life in the universe. Mars is not just cold and empty, it's violent. Meteorites constantly crash into its surface, creating shock waves faster than the speed of sound. The soil is filled with perchlorates, toxic chemicals that can break down essential biological molecules. On top of that, Mars has almost no atmosphere, intense radiation, and extreme temperature changes. In simple terms, it's one of the most hostile environments imaginable. And yet, scientists wanted to know, could life still survive there? To test this, researchers turned to yeast cells, the same organism used in baking and brewing. Even though yeast is simple, it shares many core biological systems with humans, making it a powerful model to study life. If something as simple as yeast can survive Mars-like conditions, it suggests that life doesn't need perfect environments to exist. In a lab, scientists recreated Mars-like stress using a specialized setup. They exposed yeast cells to shock waves traveling at 5.6 times the speed of sound, similar to what happens when meteorites impact Mars. Then they introduced perchlorates, the same toxic salts found in Martian soil. Finally, they combined both stresses, shock waves and toxic chemicals, creating one of the harshest survival tests possible. And here's the surprising part. The yeast didn't die. Their growth slowed down, and they took time to recover, but they survived. Even after extreme shock and chemical exposure, the cells were still alive. This suggests that life is far more resilient than we previously thought. So how did they do it? Inside the cells, scientists discovered a powerful survival mechanism. When the yeast experienced stress, they formed special structures called ribonucleoprotein condensates, or RNP condensates. You can think of these as emergency protective clusters made of RNA and proteins. These structures help protect genetic material, pause non-essential functions, and allow the cell to recover once conditions improve. Two key types of these structures are stress granules and P-bodies. Shock waves triggered both, while toxic perchlorates mainly triggered P-bodies. It's like the cell switches into survival mode to protect itself. To prove how important these structures are, scientists modified some yeast cells so they couldn't form these protective clusters. The result was dramatic. These cells struggled to survive and showed significantly reduced growth under the same conditions. This confirmed that these tiny molecular structures are essential for surviving extreme environments. Now, think about what this means. If simple cells on Earth can survive shock waves and toxic chemicals, what about Mars? The planet has experienced meteor impacts, contains chemical-rich soil, and once had water. It's possible that microbial life may have existed in the past, or could still exist today, hidden beneath the surface. Even more exciting, this survival strategy might be universal. Life anywhere in the universe could be using similar mechanisms to endure extreme conditions. Because in the end, life doesn't need perfect conditions. It just needs a way to survive. And maybe, just maybe, it already has.